Welcome to this final review explainer on electromagnetic waves. I'm your host, and honestly, I am so excited to be your guide today. Think of me as your helpful teacher, right here with you during this final review session to help you study and completely grasp the physics of the invisible forces that literally power our modern world. We're going to break down all those complex physics terms into easy, everyday language. By the end of this explainer, you're going to have a rock-solid understanding of these concepts for your exam. Let's get started.
Here is our study guide for today's session. We'll be covering 1. Unifying electricity and magnetism, 2. Anatomy of an EM wave, 3. Radio and microwave applications, 4. Infrared and visible light, 5. High-energy waves and radiation, and finally, 6. The invisible infrastructure.
Section 1. Unifying electricity and magnetism, finding the missing puzzle piece.
To really understand electromagnetic waves, we first need to look at a massive historical problem. For the longest time, physicists relied on Ampere's law, which states that a current creates a magnetic field. But Ampere's law actually failed inside a charging capacitor. Why? Well, because across that vacuum space, literally no physical current flows, yet a magnetic field still mysteriously exists. It was a glaring flaw. Enter James Clerk Maxwell. He came along and introduced his ingenious displacement bridge, proving mathematically that a changing electric flux inside that vacuum produces a magnetic field that perfectly mirrors a physical current. This single, brilliant insight allowed for what we call the grand unification. Maxwell's equations mathematically express all the basic laws of electromagnetism. So the absolute crucial point here is that moving charges and changing electric fields create magnetic fields. He essentially wove electricity and magnetism together into one continuous, inseparable fabric.
Section 2. Anatomy of an ME wave, deconstructing the invisible.
Before we look at the exact anatomy, we really need to address a super common misconception students often have. People tend to think of waves like ocean waves in water or sound waves traveling through the air. They think a wave always needs a material or a medium to travel through. But the most important core property you need to memorize right now is that electromagnetic waves are self-sustaining oscillations that require absolutely no physical medium. They can travel perfectly across a complete empty vacuum. Picture a perfectly synchronized dance moving through space. The electric field oscillates up and down on the x-axis, while the magnetic field oscillates side to side on a perpendicular y-axis. The wave itself propagates or travels forward on the z-axis, which is perpendicular to both of them. It's just a beautiful, self-perpetuating system. But how fast does this dance actually move? Well, because a vacuum has an intrinsic, unchanging resistance to magnetic fields, which we call permeability, and to electric fields, called permittivity, theoretical physics dictates a strict universal speed limit. When you plug those intrinsic vacuum constants into Maxwell's math, it spits out exactly 300 million meters per second. And guess what? That happens to be exactly the speed of light, definitively proving that light itself is an electromagnetic wave. To really lock this in for your exam, let's use a simple analogy. Think of it like a self-building bridge, or maybe an endless relay race. It all starts with step 1. An oscillating charge accelerates. In step 2, that acceleration creates a changing electric field. Step 3, just as Maxwell predicted, that changing electric field creates a changing magnetic field. And then step 4, that magnetic field regenerates the electric field. They just keep passing the baton back and forth, allowing the wave to continuously carry data over massive distances.
Okay, now that we know how they're born and how they travel, let's transition from textbook theory to reality. It's time to answer the big question. How do these invisible waves actually impact our everyday modern technology?
Section 3. Radio and microwave applications, the macroscopic scales.
Let's see how this builds into the tech you literally use every single day. Massive radio waves, which are greater than 0.1 meters in length, are produced by accelerated charge currents in aerials, like towering cell phone masts. Meanwhile, microwaves are incredibly special because their wavelength perfectly matches the resonant frequency of water molecules. Make sure you jot these practical applications down for the test. Radio waves are the absolute backbone of current global wireless connectivity. They give us AM, FM, TV, and our vital cellular networks. Microwaves, which range from 0.1 meters to 1 millimeter, are heavily used in aviation radar. But the most common everyday example is, of course, the microwave oven in your kitchen. Because it matches that resonant frequency we just talked about, it efficiently transfers kinetic energy directly into the water molecules of your food, vibrating them rapidly to heat up your dinner. It's just a perfect application of wave physics.
Section 4. Infrared and visible light, the thermal and the visible.
Looking at the Earth's atmospheric layers, infrared waves are essentially heat waves driven by the vibration of atoms in hot bodies. Visible light, on the other hand, is that incredibly narrow band of solar radiation sitting right between 700 and 400 nanometers, which comes beaming down from the sun. The crucial takeaway here is how these specific wavelengths interact with our world. Our human biology literally evolved specifically to detect that tiny visible band of 700 to 400 nanometers. Meanwhile, our atmosphere's carbon dioxide and water vapor are uniquely tuned to absorb infrared waves. So when the Earth's surface re-radiates heat as infrared, those greenhouse gases absorb it and trap it, driving the greenhouse effect that warms our entire planet. Section 5. High energy waves and radiation, UV, X-ray, and gamma.
Notice the incredible shift in scale here. Ultraviolet waves involve inner shell electrons dropping energy levels. X-rays are generated by bombarding metal targets with high-energy electrons, and the absolute smallest, tightest waves, gamma rays, are produced by the actual radioactive decay of a nucleus itself.
Now, because these waves carry so much energy, we absolutely have to talk about safe exposure limits. High energy means these waves can ionize atoms and destroy living tissue, which is exactly why we wear sunscreen to protect against UV and why doctors use lead shields during X-rays. Thankfully, the Earth's ozone layer absorbs much of the harmful UV. But when heavily controlled by scientists and doctors, this destructive power becomes a total medical miracle. We use highly targeted UV for precision LASIK eye surgery, X-rays to image inside our bodies, and deeply penetrating gamma rays specifically to target and destroy cancer cells.
Section 6. The Invisible Infrastructure. Your diagnostic cheat sheet.
I highly recommend pausing this explainer right here. Take a screenshot or write this down. This table perfectly summarizes the entire spectrum by wavelength range, production source, and detection device. I promised you 2 effective techniques for memorizing this order, so here they are. First, sort them visually by wavelength size. Start macro with radio waves and work your way all the way down to the microscopic gamma rays. Second, memorize them by their production source. Notice how the top starts with basic accelerated electrons and areals, moves through atomic vibrations and electron drops in the middle for heat and light, and then ends at the bottom with profound nuclear decay. It's a continuous, logical progression of energy.
To quickly recap, we've successfully covered the 3 foundational pillars of electromagnetism. Pillar 1, Maxwell's theoretical unification of electricity and magnetism via his displacement current. Pillar 2, the actual mechanism, those self-sustaining perpendicular oscillations that propagate flawlessly without needing any physical medium at all. And Pillar 3, the limitless applications across the spectrum that essentially give us our modern world.
Keep this quote in the back of your mind as you head into your exam. An infinite spectrum defined by wavelength, shaping the entirety of human technology. It is truly astonishing that a single mathematical phenomenon, differentiated only by the physical length of its wave, literally dictates everything from the warmth of the sun and human vision to global cell phone networks and life-saving medical devices.
So, as we wrap up this review explainer, I want to leave you with this one final provocative thought. If a scientist like James Clerk Maxwell could sit down and mathematically unify electricity and magnetism out of thin air to solve an invisible mystery inside a capacitor, what other invisible forces are shaping the universe right in front of us, just waiting for the next great mind to achieve the next grand unification? Good luck studying and stay curious.